Okay, last section we looked at a graph that represented the amount of t-shirts they needed to sell to reach their donation goal, and the graph is there. So what was the slope of the equation and what did it represent? Review from last time, remember slope is rise over run. So looking at the 2 points, how far did we rise and how far did we run? Well, we rose 180 t-shirts and we ran 3 hours. So slope of the equation was 180 over 3 or 60. But now it's asking what did that represent? Looking at this, again, the t-shirts that they had to sell per hour to get their goal. So they needed to sell 60 t-shirts per hour. Okay, remember, slope is rise over run. Now it says we're supposed to write an equation that represents that situation. Okay, so we're looking at, again, 60 t-shirts per hour. So the two things that we're looking at are t-shirts and hours. So we have T and we have H. Looking at how we're going to write this, the t-shirts equal 60 per hour. Okay, so looking at this sentence, all I did was I translated it. Is that, again, we needed how many t-shirts? We sold 60 per hour. Okay. Looking at this graph real quick, realize that it goes through 0, 0, which means that at the first hour we sold no t-shirts. Okay, looking at here, we didn't add anything on. Again, every hour we are getting those 60 t-shirts. We didn't sell any to start with. Okay, so we just had T equals 60H. All right, moving on, it says they also got Coca-Cola to donate some money and let them sell cups with the Coca-Cola logo on them. This situation can be represented by this following graph. So again, we're dealing with cups and then money made. So question 3 says, how much did Coca-Cola donate? Well, we're supposed to be able to see that from the graph. Okay, looking at this, if we had 0 cups, it looks like we were already at $150. So this y-intercept is going to tell us how much they donated. They donated $150. Okay, and again, how do we know that? Because we're looking at what this graph, we're interpreting this graph and saying 0 cups, we still have 150 bucks, or we already have 150 bucks in our pocket. Now we're supposed to find the cost of each cup. So we're going to have to look at the difference between each one of these. And this is where it gets kind of tricky, because looking at a graph, we always have to find where it crosses an integer pretty decently. So I'm going to say that right here, it does a pretty good job at 5 cups. Okay, so we started at $150 and we went up 150 with 5 cups. Okay, so looking at this again, $150 and 5 cups. There's some pretty spendy cups, but $30 per cup. How did we find that? Technically, we looked at the slope of this equation. We went up 150 and over 5. And again, I just picked 2 pretty good points that went through an integer, so I understood that that was a full cup that I was comparing right there. Now we're supposed to write an equation that represents this situation. Okay, again, I'm dealing with cups and I'm dealing with money made. So how am I going to say this in a sentence? The money we make is the $30 per cup plus the $150 donation. Okay, so again, writing equations, sometimes that's the best way to start. So the money made is $30 per cup plus the $150 donation. Okay, with that in mind, now I know what my equation can look like. All I'm going to do is translate that. Money made, I should probably make an M instead of a C. Okay, so money made is, we know is equal $30 per cup. So we have to multiply each one by that $30 plus the $150 donation. Okay, so again, writing equations, interpreting it from a graph or sometimes from a table, best way to do it. Look at it, understand what it's saying, write that in a sentence, and then translate. Okay, let's look at the difference between this one. Last graph that we looked at went through 0, 0. This one doesn't. This goes through 0, 150. So our y-intercept is a little bit different. Also notice that we're not just looking at, okay, 30 bucks per cup. All I have to do is plug in a number and know how much we have. We have to add on that $150. And that's what we're doing in this section. We're looking at the difference between proportional and non-proportional relationships. Our t-shirt graph was proportional because it went through 0, 0. Okay, the amount of t-shirts that we sold is directly proportional to how many hours we've been selling them. Our Coca-Cola problem is non-proportional because, again, it doesn't pass through that 0, 0. So the amount of cups that we're selling is not directly proportional to how much money we made because we already had some money in our pocket. So 2 new vocab words that we're going to work on in this section. Go ahead and get out the notes and vocab for this section. Objective of this section is to interpret unit rate as a slope in a proportional relationship. So we've looked at unit rate and slope so far. We're looking at that proportional vocab today a little bit. Okay, it says that if the relationship between the domain and range of a relation is linear, the relationship can be described as a linear equation. If the equation is of the form y equals kx, then the relationship is proportional. So let's go back to our t-shirts. Our t-shirts was a good example. We had, I'm not going to use y because we had the cost. Or the, goodness gracious, sorry. T-shirts equaled 60 per hour. Okay, that's in that form. That k is just a number. That's the coefficient. Then the relationship is proportional. In a proportional relationship, the graph will pass through 0, 0. So right there, notice that that passes through 0, 0. Direct variations are proportional relationships, which is just, again, synonymous. Direct variation and proportional are the same thing. So the couple rules that happen with this proportional relationship, again, they pass through 0, 0. Notice that we are not adding on anything in the equation. Looking at examples here, the ratio of the value of x to y is constant, and notice that we start at 0, 0 for both of them. So those are the 3 different types of tricks depending on what we're looking at. Are we looking at an equation, a table, or a graph? Okay. All right, real world example 1, it says Marcos is a personal trainer at a gym. In addition to his salary, he also receives a bonus for each client he sees. So we're looking at the number of clients that he has and then the bonus pay that he gets for them. So we're supposed to graph this data, and then what can we deduce from the pattern about the relationship between the number of clients and that bonus pay? Okay, pattern. A lot of times that word is synonymous with slope. They mean the same thing. So basically we're going to look for the slope of this. All right, so here we are going to see this as clients, and we are going to see this as bonus pay. Okay, we have 5 clients, so I'm going to skip to make this look kind of nice. We have to go all the way up to 225 So honestly, why don't we go by 45s? Make this thing look really nice. 45 and 90 and 135. Again, as long as it's a consistent pattern, you should be okay. So one client is 45, two is 90, three is 135, four is 180, and five is 225. So right away, we should see, again, that we have a linear relationship. We have to go further with this. What can we deduce from the pattern about the relationship between the number of clients and the bonus pay? Well, let's look at this. It looks like every single time that he gets a new client, he's adding on $45. Okay, so a couple of things. The pattern is constant. We're going to say that because, again, that means that this is a linear equation, and he is receiving $45 for each new client that he has. So pattern is consistent. So that means that graph is linear. Okay, so we talked about the graph. Now we're going to look at the bonus pay. He receives $45 for each new client. Okay, now we have to write an equation to describe this relationship. So looks like we already have our nice little sentence right there. We are dealing with clients and we are dealing with pay. So C and P would work. Okay, he receives, the pay he receives is $45 for each new client. Okay, so maybe that's the way that we could have said it. The pay he receives is $45 for each new client. So the pay is 45 per client. Okay, one thing with this. Notice that anytime that we're writing an equation out here, this P is our dependent variable, this C is our independent variable. So if you're still kind of shaky about how to write equations, always kind of double check over here or even with a table as to if you have this right. The number that you're multiplying by your coefficient should be your independent variable. The one that you're setting it equal to should be your dependent variable. Okay, this is my x value and this is my y value. So your y value should be what you have it set equal to. Okay, it says use this equation to predict the amount of Marco's bonus if he sees 48 clients. So since we already set up our equation, we know that that means clients are 8. So we're going to plug 8 in there, do just a little bit of math, and we should end up with $360. Okay, now just really looking at tables, at graphs, analyzing them. Question, is this a proportional relationship? Yes. Okay, noticing that if we did connect these dots, which we couldn't, but if we kept that pattern going, if he had no clients, he has no money. So proportional relationship. Seeing that in the graph as well as our equation because we did not add on any money. All right, go ahead and try that with guided practice number 1. Okay, same type of concept. We graphed that data. Again, you could use different numbers for your y values. I just quickly noticed that, yes, there was a pattern that it was going up by 75 each time. So I went ahead and used that pattern in my graph. What can we deduce from this? Two different things. The graph is linear, but it's also proportional. So it's a linear and proportional equation, which means, or a graph, which means that the amount of the donation received is $75 per goal. And again, I wrote that sentence like that because that's pretty easy to translate. The amount of donation is $75 per goal. Now we're supposed to use that equation to predict how much money will be donated for 12 goals. Well, if G equals 12, I went ahead and plugged that 12 in. But then I went even further and I wrote this, and if you remember that fancy function notation. So instead of just putting d out here, I did d of 12. Because remember that when we write that as an equation in function notation, this means that the donations for 12 goals is $900. So a nice review of function notation, because again, this piece right here is just helping us relate that $900 to the 12 goals. All right, moving on to non-proportional relationships. It says that some linear equations can represent a non-proportional relationship, like our Coca-Cola example. If the ratio of the value of x to the value of y is different for selected ordered pairs that are on the line, the equation is non-proportional, and the graph will not pass through 0, 0. So when we're looking at that ratio, another way you could have checked that is to take this 75 divided by 1, gives you 75. 150 divided by 2, 75. So if you can straight divide these, we know that they're proportional. If you can't and you get different numbers, we understand it's not proportional. So another good little check. All right, now example 2. We're supposed to write an equation and function notation for this graph. Okay, we did this already with Coca-Cola. So let's go ahead and pretend that we're dealing with something here. How about we say that we're dealing with hours? Because sometimes this is an easier way to see this. Let's deal with hours and ice cream sold. Okay. It looks like we are selling 3 ice cream in 1 hour. Would you agree? Because again, this looks like 3 ice cream sold in 1 hour. Okay, so remember, that's our slope. Now we have to look at this right here. It looks like at that first hour, we had already sold 6. So I'm going to say we already sold 6 beforehand. Okay, maybe a family came in before we set up our little ice cream stand and they bought 6. So we are going to say amount of ice cream sold is 3 per hour plus 6 beforehand. With that said, we know that we're dealing with ice cream. And hours, I'm going to call him C. I don't really like using I and H. So amount of ice cream sold, C, is 3 per hour plus 6 beforehand. So there's our equation. Realize, though, that it does say function notation. So that means instead of this C, we have to rewrite that as C of H, because we have to compare our dependent value to our independent value. So I'm going to rewrite that. The only thing different I have to do is put in that of H. So I understand I'm comparing ice cream to hours. Okay. Don't let function notation scare you. That's the only difference in change. Okay, go ahead and try that for guided practice 2. If you need to compare this to 2 different things, go for it. Okay, otherwise I will let you be. These are a little bit challenging problems, but after the end of next chapter, you'll be a pro at these. So if it's kind of confusing right now, just hold on a chapter. So this table is a little bit tricky to understand because it looks like our y values are actually going down. So I thought of a situation where we would be decreasing, and I dealt with hours and chores left. So looking at this, it says after each hour, I was getting a chore done per hour because I was decreasing my chores by 1 per hour. it looks like I started with 4 because after 1 hour I only had 3 chores left. So when I started, I must have had 4. Okay, so what I did was, again, I was decreasing. That's why I have a negative here. 1 chore per hour, and I started with 4. Remember, it did say function notation, so my chores compared to my hours are negative h plus 4. Okay, now looking at B, along with my chores, I'm actually getting paid for this, not very much, but a little bit. So I'm dealing with hours and money earned. Notice where my y-intercept is, way down here at negative 4. So what does that mean? That means I owed Mom $4 before I started, but she is giving me $2 per hour. Because if you notice between each point, again, how do I find that out? I look for nice intersections that deal with whole numbers. So I looked at that y-intercept. This one does not work because, again, that's half. So I'm going to come up here to this whole one. I got $2 in 1 hour. So I was earning $2 per hour. I owed Mom 4. So M of H, money compared to hours, is 2 per hour, except I'm $4 in the hole. I'll get out after 2 hours. Okay, so these type of problems, yes, I understand a little bit tricky, but the biggest goal for this section was to understand the differences between the proportional and the non-proportional, to understand how to find that slope or that unit rate, because again, we were looking at how much money we got per hour. Okay, that's a unit rate. So if you understand those two things, you should be ready for the assignment for this section.